Projectile motion is the way objects fly when thrown into the air. This is an example. Here we see Johan juggling a ball. The initial velocity of the ball was 3.8 meters per second, and it took 0.425 seconds to reach the top. Using this equation, we can figure that it went 2.5 meters high.
Sean shooting the ball. We use this formula. We know the distance is 13.7 meters and the time is 0.65 seconds. We divide these to get 21.1 meters per second.
Here I am crossing the ball. We use this formula to find the initial velocity. We know the ball was 3 meters high and the time was 0.9 seconds, with an acceleration of negative 9.8 meters per second squared. Using this, we can figure out that the initial velocity in the y direction was 1 meter per second. Here we see Jeremy clearing a ball. If we're solving for distance, and we know that the initial velocity was 11.1 meters per second and it traveled for 3.2 seconds, we could use this equation. By plugging in these numbers, we could find out that the distance was 35.6 meters.
Acceleration in the y direction is always negative 9.8 meters per second squared due to gravity.
Here we see Johan throwing in the ball. To solve for how tall he is, we use this equation. We use the initial velocity of 0 and the final velocity of 6.2 meters per second to figure out that his hands were 1.96 meters high when he released the ball.
Here we see me kicking the ball straight up in the air, 8 meters. And here we see Jeremy kicking the ball 45.7 meters and goes 8 meters high. It takes both kicks about 2.5 seconds due to the fact that the y was 8 meters on both kicks.
The x and y direction of a projectile are completely independent from each other. A projectile is an object in motion that is only affected by gravity. Okay, so this is the equation I use the most when dealing with projectile motion problems. I don't know why, I just do. This is the problem we're going to solve today, where Jeremy kicks the ball straight up in the air at 12 meters per second. And it stays in the air for 10 seconds before hitting the ground. And we're going to solve for how high that ball gets in the air at its maximum point. Okay, so here I have everything I know so far written out, and I'm going to solve that. The reason I use 5 for the time instead of 10 is because the ball reaches its maximum height halfway through the time elapsed before it touches the ground. Okay, so now I have simplified the problem to its bare minimum. I've already gone through all these steps, simplifying it to 60 plus negative 122, and that will give us the answer. Okay, and our final answer for this problem will be negative 62. It doesn't really matter that it's negative because you can't really go in the negative direction in the real world, so we'll just change that to positive. And that's how you use this equation to figure out how high a ball goes in the air using only the initial velocity and the time it was in the air.